Hello friends, this is Urmila and in this video we are going to see basic logic gates. Logic gate is basic building block of any digital system. You can consider a logic gate as a box having one or many inputs and only one output. The logic gate is building block of a digital system and hence the inputs and output are in the form of zeros and ones. The inputs and output are in binary form. The output is produced depending on the specific logic of that logic gate. When the inputs are in the form of zeros and ones, the one input can be referred as high or true and the zero input can be referred as low or false. So, while expressing the logic of a gate, 1 can be referred as true or high and 0 can be referred as false or low. Every logic gate is having its own symbol which is used to represent that gate in the circuit. Every logic gate has its own logic. There is a Boolean expression which expresses the behavior of a gate, and there is a truth table which summarizes the logic operation of that gate. We are going to see three basic gates and all these four things for each gate. What is Boolean expression? Boolean expression is a mathematical form of that logic operation. The mathematician George Boole have developed an algebra which relates logic gates and mathematics together. When the logic operations are expressed in terms of equations, these equations are called as Boolean expressions. And the truth table summarizes the different possible combinations of inputs and the respected outputs. We are going to study three basic gates: AND gate, OR gate and NOT gate. These are the types depending on the logic operations performed by these gates. Let us see the first gate, AND gate. The AND gate is having this type of circuit symbol and the logic of this gate is this statement. Logic is a statement which explains the behavior of a gate. What is the behavior of AND gate? When A is high and B is high, then Y is high. When the gate is having two inputs A and B, and when A is high and B is high, then Y, the output, is high. The AND operation is expressed using Boolean expression as Y is equal to A dot B. This is dot or AND operator. The AND operation can be understood using or taking the analogy of this circuit. See, in this circuit there is a power supply and LED is connected in series with the power supply. There are two switches added in series with in the loop, and the two switches are also in series with each other. When there is current flow through LED, the LED will glow, and the glowing condition, on condition of LED can be considered as high output, and the closed conditions of switches are considered as high inputs. So, you can see here in this circuit, when A and B both the switches are closed, then only there will be current flow through the loop and the LED will glow. That means when A and B both are high, Y will be high. If any one switch is open, the loop will be open, there will be no current through the loop and hence LED will be off. That means when A or B, any one input is low, output will be low, right. So this behavior is summarized here in the table. A truth table has columns for inputs and output. There are two inputs A and B, and there are four possible combinations of inputs. When two inputs are there, 2 raised to 2, that means 4 possible combinations of inputs are there. For each combination of input, y is placed here depending on the logic of AND gate. When A is high and B is high, then Y is high. See here. In these possible combinations, the last combination is A is high and B is high. For this combination only, Y is high or 1. When any one input is 0, the output is 0. Okay. If you have multiple input AND gate, that means more than 2 inputs are there, to generalize, you can say that when any one input of AND gate is 0, the output is 0. And when all the inputs of AND gate are high, 1, then the output of AND gate is 1. Let us move forward. The second gate is OR gate. The OR logic is expressed here. When A is high or B is high, then Y is high. The two inputs A and B, and when A is high or B is high, Y is high. This is the logic of OR gate. And the Boolean expression for OR gate is Y is equal to A or B. This is OR operator, and the expression is A or B. It is just like summing operator, and hence the summation sign is used here. We can take analogy of this circuit to understand the OR operation. Here the same circuit which we have seen earlier is there, but now the switches are connected in parallel with each other. When any one switch is closed, the current will flow through that switch and the LED will glow. That means when A is closed or B is closed, the loop will be closed and the LED will glow. Output will be 1 high, right. So A or B, the parallel combination of switches gives you OR operation. This OR operation is summarized here in the truth table. When A or B is high, or both A and B both are high, then the output of OR gate is high. When both the inputs are 0, then only the output of OR gate is 0. If you have multiple inputs OR gate, that means more than 2 inputs, then you can say that when any one input of all these out of all these inputs is high, then output will be high, and when all the inputs of OR gate are 0, then only the output of OR gate will be 0. Let us move forward to the next basic gate, that is NOT gate. NOT gate is also called as an inverter because it performs inversion operation. This is the circuit symbol of NOT gate. The bubble indicates inversion. What is the logic? The logic of NOT gate is when A is high, then Y is low. There is only one input. NOT gate is single input gate. It cannot have multiple inputs. So only one input is there, and when that input is high, then Y is low. That means the input is getting inverted. The Boolean expression for NOT gate is Y is equal to A bar. You know A bar, this is 1's complement of A. So 1's complement means inversion. You can take analogy of this circuit. Here what is done, a switch is connected in parallel with LED. When the switch is closed, the current will flow through the switch and not through the LED, and hence the LED will be off then. And when switch is open, then the current will flow through LED and LED will glow. That means when switch is open, input 0, LED will glow, output 1, right. So inversion operation. And here in the truth table, since only one input is there, so there is a column for A only, and 2 raised to 1 combinations, that means 2 combinations, either A is 0 or A is 1, and when A is low, Y is high, and when A is high, Y is low, inversion operation. So this is how we have studied 3 basic gates. If you like this video, do share it with your good friends, and you can subscribe this channel to see more such videos. In the next video, we are going to see derived gates.